This is page 4, problem number 5, gas law problems. If a balloon is filled with 0.25 liters of a gas at a pressure of 101.3 kilopascals and a temperature of 100.0 degrees Celsius, the pressure of the balloon is reduced to 25 torr and a volume of 100 milliliters. What is the new temperature in Celsius? Give you a warning. This is going to require 2 steps. First step, find the temperature in Kelvin. Second step, convert to degrees Celsius. I want to talk a little bit about the formula that you're going to be using. P1 V1 over T1 equaling P2 V2 over T2. You may have noticed that I give this formula in a second version, and I give it as P1 V1 times T2 equaling P2 V2 times T1. And the reason I do that is because, for example, in this problem where I'm looking for what's the new temperature, right here is my new temperature. That's T2. All I have to do is take both sides and divide by P1 V1, and I'm done with my algebra. It works for any of these 6 variables. So I'm going to go ahead and I'm going to copy that because that's the formula I need. I'm just going to kind of put it right here for right now, and we'll come back to it in a second. Let's identify the variables that we have. We know that we have P1, V1, and T1, and P2, V2, and T2, with T2 being unknown. Our initial pressure is 101.3 kilopascals. Our initial volume is 0.25 liters. Our initial temperature is 100 degrees Celsius. Our second pressure, so the resulting pressure, is 25 torr, and the volume is 100 milliliters. There's lots to make sure that we cover and convert. Kilopascals and torr, not the same thing. Got to change it. Similar to problem number 5 on page 3, this is an easy conversion. That's 760 torr is 101.3 kilopascals. So this is 760 torr. Liters and milliliters. Let's change this. 0.100 liters. And that's in Celsius, so it must go to being Kelvin. So that gives us 373 Kelvin. All of our units now agree. Torr and torr for pressure, liter and liter for volume, and Kelvin for temperature. We have our formula. We can plug it in. We have P2, so that's 25 torr, times V2, which is 0.100 liters, times T1, 373 Kelvin, divided by 760 torr times 0.25 liters. Pointing out again that I have placed my pressures over each other, my volumes over each other. Another check to make sure my temperature is in Kelvin before I do any math. When I plug it all in, I get T2 being 4.91 Kelvin. But I need to change that back to degrees Celsius. The way I do it, I subtract 273. That gives me negative 268 degrees Celsius.